Welcome to the iterative AI session. This is the whole team, and we'll be here to answer any questions that you have after the presentation. So, in honor of all of the virtualness, let me try to share my screen. It worked a second ago, so let's see if, yeah, okay, that looks like it's still working. I'm gonna be hopping around screens a little bit, but hopefully it's not too much to keep up with. So today I'm going to be talking to you about tuning hyperparameters with DVC experiments. And my name is Melisha McGregor. I'm a developer advocate with Iterative, but I specifically focus on DVC. And my background is a little bit all over the place. I have a master's degree in mechanical and aerospace engineering. I've worked on autonomous vehicles where I helped write some code to do some online machine learning, which was interesting. And I've worked pretty much every part of the web development stack, full front end, back, databases, DevOps, whatever, styles, you name it. I've probably touched it at some point. But that's a little bit about me. And without further ado, I'll go ahead and get started. But if you do have some questions that you want to ask throughout, feel free to reach out to me on Twitter at Flipped Coding, or you can reach out to us directly at DVC.org on Twitter. Well, there we go. So at the beginning of all my talks, I like to give a quick overview so that you know when you can kind of zone in and out since everything is online. But the first thing we'll talk about is a little background on tuning hyperparameters. We'll go over using DVC, so how we actually get the most benefit out of this tool. Then we'll do an example of using DVC with grid search, so a little bit of live coding going on. And we'll briefly talk about random search. And we'll wrap up with just a few key takeaways, some things that I hope will help you later on in your machine learning projects. But first, a little background on tuning hyperparameters. So these are the parameters that define the model. That means they address certain design questions like, what degree of polynomial features should you use for a linear model, or how many trees should you include in your random forest, or maybe how many neurons you should have in your neural network layer. These parameters are usually found during this process of hyperparameter tuning. And that's basically where we look for the ideal model. So what is going to give us the best results with our data as efficiently as possible? But that's not to be confused with the results we get back from directly training with the data. This isn't the same as our model parameters because those are learned during training when we're optimizing some kind of loss function like gradient descent, but hyperparameters are not model parameters. So you can't get those from the data, which leads us to this great journey of tuning them. And that's where we basically come up with a good enough guess of what hyperparameters might be a good starting point for our model. And then we can figure out what might need to be tweaked to make this model more optimal. And this is where DVC comes in. So the main thing with hyperparameter tuning is that sometimes you're just playing around with different values and you're not really expecting a good change to happen. And then your accuracy increases ridiculously fast or something happens. And now you're wondering, what exactly did you change to get that result? It might have been something in the code. It might have been a specific parameter value. But the problem is that change or the combination of changes is just gone. And that's why we bring in a tool like DVC. It tracks all of the code changes, hyperparameter updates, and any changes in your data. So if you're in the middle of tuning your hyperparameters and you've been training this model, but you get new data and all of a sudden you need to update things, and it might affect the way that your hyperparameter values are chosen. With DVC, you don't have to wonder, oh, which accuracy is associated with what changes. DVC takes care of that for you. And since it tracks all of these changes, that means your hyperparameter tuning is super reproducible. So if you want to share this project with another machine learning team, or you're onboarding a new engineer, you're able to take them through every step of your hyperparameter tuning process. They can see where all of the little changes in your code and hyperparameters made a big difference for your model. It's not, oh, well, they were just over there one day and we got lucky with the right set of values and we just don't touch that anymore. But with DVC, you don't have that problem because everything is tracked and it's easy to go back to those instances that you might want to experiment with a little bit more. And since you can roll back or pick up from where you left off, having reproducibility makes it a lot safer to just try new things. You don't have to worry about, oh, well, I made this code update and I added a max depth to my random forest classifier. You don't have to worry about remembering all of these things. You can just get in there, play around, run your experiment, and it's tracked for you. So you actually get to have fun with this again. And now let's talk about one of the main methods of tuning hyperparameters, which is grid search. So with grid search, you select a finite set of values for each hyperparameter. Let's say you have 3 or 4 different hyperparameters and you want to test 100 values per parameter or something like that. You would feed your script this set of values and it'll iterate through all of them. This does an exhaustive search over every value that you input. So if you have any questions, like you want to increment a step value by 0.5%, you can do that and grid search will carry out every tiny change in each hyperparameter. So now is the fun part. We're going to go to a little bit of live code. Let's see if we can keep the luck going here. So right now we're in Visual Studio Code and I already have a project set up. So this is just any machine learning project. We have a couple of scripts in here that handle training. We have some data, all that good stuff. But the main thing I want to point out is if you have an existing project, you can add DVC to it with just a 1-line command of DVC init. And this creates your DVC pipeline. That will bring in this .dvc directory that has all of the configs you need to work with. And it brings in this DVC ignore, which you don't have to worry about that. But the next thing you'll do once you have that pipeline in place, you'll add what's called a stage. And to do that, you'll run DVC stage add, and you'll give it some kind of name. So we'll say we have a training stage, and we'll add a dependency of our train script in here. So you'll run this command. I'm not going to do that because we already have this stage created. So I'll delete that out of the terminal. But I just wanted to show you how quick and easy it is to add a stage to a pipeline once you have it set up. But after you've added a stage, it'll create this dvc.yaml file. And this just holds all of the things you need for your stage to run. So we have the command. We know that we want to execute this train script. We know we have to have the data in here because it's a dependency. And then we have some parameters. This is the good part. A lot of times when you're doing hyperparameter tuning, you have just this one config file with all of your parameters in it for all of the steps you need to train your model. But with DVC, you can actually have these separated in like little granular chunks in something like a params.yaml file. As you can see here, we have different hyperparameters for different stages, but our focus is down here in our training stage. And if you'll notice, these values correspond to what's in our params here. Basically, whenever these parameter values are changed, that will trigger this training script to run again, and it will update our accuracy. And this has some rock AUC values associated with it. But that's one of the ways that DVC helps with hyperparameter tuning. Now we're going to get to an actual fun part. So I'm going to run an experiment with DVC exp run. Might need to update a parameter. Yep. So in this case, we'll update, I don't know, let's make the min split 32. And I'll run DVC exp run. Uh-oh. Oh no, don't go bad live coding. Let me try this. Maybe. Oh, it's a really simple thing. I'm not in my virtual environment. Let me do that real quick. And then undo that change. And now I'll run this experiment. There we go. So make sure that you have your virtual environment set up before you run any DVC experiments. But we run this experiment with these hyperparameters, and you can take a look at those values using DVC exp show. And you'll see this is our output for that one experiment. It's not a bad average precision, but what we want to see is if we change those hyperparameters, will it get us a better value? And to do that in the best way possible, we're going to take advantage of something else in DVC. We have a queuing system for experiments. So I'm going to set up a couple of queues by doing DVC exp run with the queue flag. And then this -s sets a parameter. So we're going to set the train.minSplit equal to, let's just go up to 34. And you'll see we have an experiment queued. And now I'm just going to use the up arrow in the terminal to make a few more of these. So we'll have one at 36. Let's do a 38 and a 32 and a 30. Okay, now we have several experiments queued, and all of these are different hyperparameter values that we want to see how they affect the accuracy of our model. To run these, we'll use DVC exp run, and we'll use, let me get that. Then we'll use the --run all, and we'll just run 2 jobs in parallel. So what's going to happen here is DVC is going to run all of those experiments with all of those different hyperparameter values and give us a nice little table at the end. But the point of doing this is that you can easily make a script to go through arrays of hyperparameter values and just spin up queues. So you could automate this to do your hyperparameter search for you while it's tracking changes in DVC. So let's take a look at that table with DVC EXP show. And now, if I can get this, oh, of course, it's not showing over there. Let me run another command to clean up that table a little bit. So I'm gonna add a few different flags. I'll clear this terminal and we'll run dvc exp show, and I'll just say include params, and we'll include all of the train params. Or at least these couple. Let's just go with these couple. Okay, now you can see how our queues updated the average precision based on these different min split values. It looks like, what, 36 for min split did the best. So let's take a little bit of a closer look at this. Say we want to look at just a quick comparison between two different metrics or two different experiments. Let's run DVC metrics diff. And the great part about running experiments, since it tracks everything, there's an ID associated with it. And that means you can grab specific experiments and look at them in more detail, even right here in the terminal. So I'm gonna choose, let's look at this one, and we'll look at, let's look at the best one, why not? So this command just gives us a quick little terminal printout here of what the average precision in the ROC AUC were. The old value corresponds to whatever we put in first. The new value corresponds to the experiment ID we put in second. And it shows you just some small stats. So you'll notice that from the old experiment to the new one, we got this, what is that? A 1% change? That's pretty significant difference, right? And we got our ROC AUC to go down by a little bit, but getting that percentage plus change in our average precision, that's a pretty huge deal. And we did it in what, a few minutes? So this is where some of that value comes from. Now, if you want to look at the difference in, say, a plot, maybe you need to do a report to show everybody why all of this research you're doing is so important. You'll do that with DVC plots diff, and I'll use those same IDs. And this just generates a little plots.html file that I should have opened. And if I refresh it, there. So you can see the difference in your precision over the training interval between the two different experiment runs. And this might help you when you're in meetings or just whenever you need to visually look at these diffs between experiments. So if I come back here, then I'm just going to clear out the terminal, and let's pick back up in the presentation. So that's how you do a grid search with DVC. Hopefully you see that setting up queues doesn't take very much time. Once you know which hyperparameter values you want to use, you can set up as many queues as you like. You can do that programmatically. If I want to switch back here real quick and go up to one of the queues, you can make a quick little Python script where you replace the value for the min split dynamically from an array or something. So it's not too bad to set up a grid search if you already have the values that you want to cycle through. Now I'll go back to the presentation. So we've seen what grid search looks like, and there is one more method that's used in hyperparameter tuning, and it's random search. We won't do a demo of this with DVC because random search is quite a bit more complex, but it is also possible to set up a script to handle this with DVC experiments. But just so you have a little background on it, random search does outperform grid search when a very small number of the hyperparameters have a big effect on the final performance of your model. So maybe you have 10 different hyperparameters, but only 3 of them actually make a difference. That will give you a really fast way to narrow down the values that make the most impact, because you won't be doing a huge extensive search over all of the values for all of the hyperparameters. You can pin things down pretty quickly. And this is usually better for lower dimensional data, because when you start working with a lot more data or higher dimension data, it just takes a while to hop around randomly, and you have so many different options to hop around between. But I hope that the little demo of doing grid search with DVC was helpful, and you see how it can apply to your machine learning projects. Just remember that reproducibility is actually really important when you just spend some time playing around with values and you don't have a way to track them. But tuning your hyperparameters, if you have a way to do it quickly and methodically, it'll make your model better faster. So those average precision increases of like 1% or more, they'll happen in a shorter amount of time than a year's worth of research. So just keep that in mind when you're thinking about maybe not tuning your hyperparameters as long. And DVC helps you to tune your hyperparameters because it helps version your data, it tracks your code changes, it tracks your hyperparameter changes. Basically everything you need to tune hyperparameters, it keeps track of it for you. That way, when you are bringing on somebody new to a project, or you're trying to show stakeholders the increase in your accuracy over time, DVC will help you generate all of that pretty quickly. Like, you can put together plenty of graphs, you can put together tables and charts just based on the values that you get back from DVC tracking experiments over time. And then this is just a personal favorite. Don't be afraid to try new tools, even if it's not DVC, which of course I hope it is because it's a pretty cool tool. But even if you decide to try other tools, just don't be afraid to try them. It gives you a little bit more understanding of the problem that you're working with, and it gives you more exposure to the different ways you can approach it and solve it. So with that being said, that's the end of the presentation for today. My name is Melisha, and you can find me on Twitter at Flipped Coding, or you can reach out to the whole team on Twitter at dvc.org. So we are open for questions. Oh, we should probably introduce everybody on the team. So if y'all want to turn your cameras on and say hi to everybody.
Hi, I'm Jenny, Community Manager.
Hello everyone, I'm Dmitry. I created the DVC initially, and now we work as a team on the product and some different products.
Hi, and I'm Jervis. I work on the marketing team here.
All right. Did anybody have any questions for us about, I don't know, the presentation or DVC in general?
Yeah, it's a question about deployment and triggering deployment pipeline. I think it's related to CI/CD, and we have another project which is called CML, Continuous Machine Learning. The idea is basically, when you create a commit or push commit to GitHub, you can trigger some separate process, CI/CD process, and then you can, as part of this process, you can train model, validate model, or push model to production. It's a question not about DVC, it's about like workflow in general. If it answers the question.
I'm putting the link to CML in the chat.
And then there's actually one more really cool, easy way that you can tune hyperparameters or do a bunch of other stuff. Let me show you that real quick. We have DVC Studio, where you don't even need to be a machine learning engineer. You can just log in here, and it's connected to your GitHub repo. And whenever you push code changes, it automatically updates everything in here. So, for example, let me pick a commit maybe. Maybe not all the way back here. But let's say I want to update the hyperparameters on this specific commit, but I don't really want to go back and do this programmatically and make a whole PR for it and maybe deal with test and deploy issues. So we'll take this min split and update it to 28. And you'll notice down here, it'll actually make a new branch for this commit and a new pull request. So we can just go ahead and commit those changes, and it'll trigger an experiment run for us. So now you can see it's running this. But just wanted to make sure that y'all knew about this tool, because it's pretty cool to just be able to tune hyperparameters with the GUI.
And this UI experiences also came down to CI/CD, because what actually happened under the hood, Militia generated a code change, right? Hyperparameter file change to Git. The system automatically pushes the change to GitHub. GitHub triggers CI/CD, and CI/CD triggers retraining, and then returns the result back to the UI.
Yeah, did anybody else have questions?
I'm adding that link too.
There is a question about MLflow.
Mm-hmm.
So I can take it, or Militia, if you prefer.
Would you mind taking that one?
I can, yeah. Suprasanan, if I pronounce the name correctly, sorry if not, is asking about MLflow, the difference between DVC and MLflow. I think the biggest difference is about how exactly the tracking happening. In MLflow, all the tracking happening from the experiment, from your user code, right? When you report metrics, report hyperparameters, and you stream kind of all the data, all the hyperparameter to some external service. While in DVC, we use Git as a foundation for all the changes. We store all the hyperparameter changes, all metrics changes as a commit. In case of experiments, kind of virtual commit. And the difference is we store everything, which is like your hyperparameters, your metrics, your code, and even data changes. So with what is the difference? You will have the full reproducibility of your experiments if you use DVC, while in MLflow you need to have some instrumentation for tracking code changes. Does it answer the question? Yeah, thank you for the question. It's a good one.
Yeah, that was a really good question.
And by the way, in addition to this question, I can add that some teams use DVC with MLflow or other experiment tracking tool. So the kind of not conflict between the tools. You can track hyperparameter with the tool you prefer, while DVC takes care of data changes and code changes. So you can have the kind of whole experience of experiments experiment tracking.
Anybody got anything else? You don't have to be shy. We're ready.
Maybe we should like sing a song or something.
What is the story of DV?
I'd like to know that too, actually. Where'd she come from? She's here.
The story. Okay, the story was in the early days of DVC, we come up with that DVC looks like a novel because like D and C and V kind of in between. It looks like a novel, and we like, all right, let's use a novel as a mascot for our projects. And then just DV flight to the office, and this, yeah, how it happened.
I gotta say, I think DV is like the best tech mascot.
Yeah, totally. She's got her hat on today too.
It's like summer hat. DV used to wear winter hat like a couple months ago. we even got a picture.
Oh, we had another question come in.
Oh, good. Studio.
Yeah. I can answer this if. Yes. SaaS service, it can be installed on prem. You can contact through the website. Yeah, we can explain like how it can happen. Because a lot of users use, like, for example, on-premise GitLab, right? And this is a way how you can connect with the studio product.
All right, anybody else have questions or comments, concerns about life?
Bitbucket question about CML. CML doesn't need to support like GitHub or GitLab specifically. In CML, it's important to support specific CI/CD system. So in this case, for Bitbucket, we do support the Bitbucket CI/CD. And some people use like different CI/CDs. So we support GitHub Actions in CML. We support GitLab CI/CD. This is like GitLab CI/CD system, Bitbucket CI/CD, and more support is coming for more tools. Like there is a Travis, Azure DevOps, and there are like a few more CI/CD systems. So we need to we will be supporting more and more.
I think the virtual world has us mastering the art of the awkward silence.
Yes. At our meetup, you should know that everybody can talk. So you're welcome to come to our next meetup on June 24th, and everybody can be on screen and everybody can talk and have a in-depth discussion about all these things. We'll be talking about experiments, different use cases for experiments, and different ways to set up DVC according to your needs and how your team works and how your data is, and all of those things. So join us. We'd like to have you.
Yes, join us.
Oh, there is a way how you can be on the screen.
Come talk to us.
I swear, if you feel nervous, you're not alone. Yeah, don't let the tooth on the necklace fool. Yeah, thanks for coming and thanks for asking all those good questions.
Yep.
Hopefully we'll see you at the meetup.
Cool. Like 41 minutes already. Should we like finish the talk, or like how it's supposed to go? Or should we wait for 45? 45, it's a limit, I guess. Okay, I think we can ramp up.
Okay.
Right.
Sounds good.
All right.
Bye, guys.
All right. Yeah. Fine.
See you next time.